Lesson 4-2, similar triangles, and in this lesson you'll learn to find the unknown measures of sides of two similar triangles. Okay, and it's important because you can use similar triangles to solve problems involving tennis, architecture, and even billiards. Rock and roll is here to stay, is what you might hear after visiting the Rock and Roll Hall of Fame and Museum in Cleveland, Ohio. Memorabilia from musicians such as the Beatles, U2, and Carlos Santana, who is in this picture, cover the walls inside. The building itself is designed by an architect I.M. Pei, is made up of several geometric forms: a triangle, a cylinder, a rectangle, and a trapezoid. The triangular section of the building is similar to the one Pei designed for the Louvre in Paris, France, and this is the Louvre in Paris, France. And it's very similar to the triangles in Cleveland, Ohio, in the Rock and Roll Hall of Fame Museum. Okay? So both are made up of similar triangles, and we say that two figures are similar if they have the same shape, but not necessarily the same size. So you have these two triangles, they have the same shape, not the, and they have the same size. Okay? And we say that if corresponding angles of two triangles have equal measures, the triangles are similar. The two triangles above are similar. We write this as triangle ABC is similar to triangle DEF. The F is not shown in this slide, but that should be an F. The order of the letters indicate the angles that correspond. What it's basically saying is that if we take a look at a little bit of what we know about corresponding angles, when you say the word correspond, okay, when angles correspond, that means they are in the same location in the triangle. So in this case, angle A in the same location as angle D. That's why they correspond. And that's how you write your triangle. In here it says triangle ABC is similar to triangle DEF, which simply means the triangle, angle A corresponds to angle D, angle B corresponds to angle E, and angle C corresponds to angle F, which is not on the screen. Okay? So if you look at the angles that correspond, again, I said that angle A corresponds to angle D. Okay, angle B and angle E correspond; they are in the same location, and angle C and angle F correspond. Okay, the corresponding sides simply mean that the sides that are in the same location of the triangle. So in this case, side AB, right here, where's AB? Right here. And side DE are corresponding sides. Okay, side BC right there, and side FE, EF's right there, and side AC and side DF. They're all corresponding sides. Okay, the sides opposite corresponding angles are called corresponding sides. Okay, compare the measures of the corresponding sides. Note that AC means the measure of side or segment AC. DF means the measure of segment DF or side DF, and so on and so forth. Okay, so again, let's take a look at this definition because these are little things that you will miss later on. The sides opposite corresponding angles are corresponding sides. Okay, so when you talk about that, when I have side AB over side DE, so I have here AB and DE, they're both corresponding, and we take a look at their measures. Side AB is 6 and DE is 18. If we simplify that fraction, we end up with 1/3. Other two corresponding sides are BC and EF. Okay, so BC and EF correspond. The measure of side BC is 5, measure of side EF is 15. Simplify that, we still end up with 1/3. And the last two corresponding sides, AC and DF, if you take the ratio of those two, okay, we have 3/9 and still end up with 1/3. Okay, so when the measures of the corresponding sides form equal ratios, the measures are said to be proportional. Okay, So let's define similar triangles. If two triangles are similar, the measures of their corresponding sides are proportional, and they're not saying they're equal, they're saying they're proportional, and the measures of their corresponding angles are equal. Okay, so in similar triangles, okay, the sides are proportional and the angles are equal. Okay, take note of that. So let's take a look at example number 1. Proportions can be used to find measures of sides of similar triangles when some measures are used. So we can use similar triangles to find out what we know, uh, to find out or to solve problems involving similar triangles. Okay. Okay. Let me just reconnect my tablet. Connection got lost. Okay. There you go. Well, we're in business. Okay. Let me just quit a few things here. Okay. So again, proportions can be used to find measures of the sides of similar triangles when some measures are known. Okay, and that goes with example number 1. Okay. Surveyors normally use instruments to measure objects that are too large or too far away to measure by hand. They can also use the shadows that objects cast to find the height of the objects without measuring them directly. How can a surveyor use a telephone pole that is 25 feet tall and casts a shadow of 20 feet long to find the height of a building that casts a shadow 52 feet long? Basically saying you have a telephone pole that's 25 feet high and casts a shadow of 20 feet. And you want to find now the height of the building, okay, that casts a shadow of 52 feet long. Okay, so this is what we want to find out. And if you notice, it forms two similar triangles, same shape, different size. So in this case, triangle, oh, before that, triangle NOP is similar to NOP is similar to MRQ. And knowing that they are similar, that means side RQ, this side RQ is corresponds to side OP, and side QM, okay, corresponds to side PM. See, corresponding sides of similar triangles are said to be proportional, so we simply equate RQ equal RQ over OP equals QM over PM. Okay, and then we substitute the values for RQ and QM and PN, and OP is what we want to find outside OP. Okay, so that is X. And knowing what we learned in the last lesson, we do cross products. So this now becomes 20 times X and 25 times 52. Okay, and then we end up with 20X equals 1,300. And dividing both sides by 20, we end up with X equals 65. So the building is 65 feet high. Okay, so that's how you use your corresponding sides of similar triangles, okay, to be able to find the height of that building. Let's take a look at example number 2. Example number 2, find the missing measures of sides if each pair of triangles below are similar. Okay, remember that the sum of the measures of the angles of a triangle equal 180. Okay, so in letter A, Well, we have to show the triangles first, and this is one triangle right there, and this is the other triangle. We want to find the missing measures of the sides of each pair of them. So in this case, we are looking for y and we're looking for x. But we have two triangles that are similar, okay? And notice, okay, you need to be able to identify your corresponding angles, because once you identify corresponding angles, you can identify your corresponding sides, okay? So the measure of angle Q is 180 minus 117 plus 27, because again, knowing that the sum of the angles in the triangle is 180, angle Q here, okay, will be the sum will be uh, will be 36, because 180 minus 27 plus 117 will give you that angle, okay, or simply 180 minus the sum of 117 plus 27, okay. So that's the measure of angle Q, okay. And then the measure of angle T, which is on the smaller triangle, okay, again it's the same thing. The sum of angle T will be 180 minus the sum of angle V and angle U, which are 117 and 36, which will give us 27 as well, okay. Another way to find this out is that if you notice that angle S corresponds to angle T, you know right away that's 27 degrees, okay. And if you look at angle Q right here, angle Q corresponds to angle V, so you know that's also 36 degrees. And that's the reason why once you find out the angles that correspond, you more or less know, okay, the measure of that angle without going through this process, okay. So since the corresponding angles have equal measures, angle QRS corresponds to angle VUT. It is important to write this because every letter now every letter indicates angles that correspond. Angle Q corresponds to angle V, angle R corresponds to angle U, and angle S corresponds to angle T. This means that the lengths of the corresponding sides are proportional as well. Okay, so let's find out. So you have, let's do a ratio of our corresponding sides. Okay, side SQ corresponds to side TV, which is equal to side QR, okay, right here, corresponds to side VU, okay. So knowing that, we simply substitute the values for SQ and TV and VU. We don't know what X is because we don't know what QR is. So we do cross products. This becomes now 12x equals 33 times 6, or 12x equals 198. Dividing both sides by 12, we find the measure of x, which is around 16.5. Okay? And let's find the measure of side SR or y. So we do our corresponding sides again. We use SQ and TV again. And equate it to a pair of corresponding sides, which are SR, okay, and TU right here, okay. So we substitute the values for SQ and TV. 33 over 12 again equals y over 8, okay, because TU is 8. And then we do cross products. We have 12y equals 33 times 8. 12y equals 264, and divide both sides by 12. Y equals 22. So the missing measures are 16.5 and 22. Okay? And that is letter A. Let's take a look at B. Triangle NRT is similar to triangle MST, and this is how it looks like right there. And the first thing you need to do here is to, so that you will not get confused, is to separate those two triangles. So let's separate those two triangles. Let me get a right angle right here. Right angle right here. Okay, and let me flip that thing. Okay, and let me clone that thing, so and then we'll make one bigger. Okay, that'll be your bigger triangle right there, and bring this one closer here. Okay, so those are our two triangles, and this is NRT. Okay, so this is NRT, and this is MST. Okay, so triangle NRT similar to MST. I just got the triangle, took it out a big triangle, so it'll be easier for us to solve. Okay, a lot less confusing. And this is S. Sorry, that's X. These two angles are congruent because of those two arcs. Okay, and the measure of MT is 28. The measure of NT is 12 meters, and this is 9 meters for RN. Okay, and SM has X, and we have right angles right there. Measures 90 degrees. Okay, so let's begin to solve this problem. Okay, we'll find our corresponding sides. We have two corresponding sides, RN and SM. RN and SM, okay, and which is equal to two more corresponding sides, NT over MT. So NT is this one, MT is that one. Substitute the values. You now have 9 over X equals 12 over 28. Using cross products, this becomes 12x times 9 times 28. Okay, end up with 12x equals 252, and divide both sides by 12, you end up with 21. Okay, so the measure of side SM is 21 meters. Okay, and that's about it. The lesson is over. Thank you for watching.